will start soon. Recording has started. And now I'm starting my screen presentation so that you will see the presentation. Okay. Is the screen visible?
Yes, sir. It's visible.
And
Yes, sir. It's clear.
yeah, and if my accent is issue, then please go for the captions. I think those captions will properly transcribe my voice in properly understandable language. We are there, statistical model. Okay. And these resources I'm going to share with you so that these resources will be helpful for you people. It's a caret web book by Max Kuhn. Then YouTube videos are there. You can click on those links. And then one caret chapter is there. Chapter which is describing the caret package from a book. Okay, you can click on those and then you can understand that. Okay. Statistical models are actually abstractions. I'm considering the audience as a beginner level audience. Yeah. And therefore we'll go with little basics. And statistical models are real life situation abstracted in form of mathematical equations, and their statistical uncertainties are considered. Okay. Those probabilities are there, rates are there, samples are there, and because of that we have to use many statistical concepts there while modeling that situation. And when we get the models, those models can be used for prediction. Again, our prediction will have statistical support. Those p-values will be there, r-square values will be there, so that, or performance metric, various performance metric are there. Those performance metric will be available or can be used to explain our prediction, to support our prediction. Okay, and general that description of model or general statement of model is response is there, and that response is because of this tilde sign. Tilde sign is because of, okay, because of the input variable. Input variable can be called as independent variable, can be explanatory variable, can be predictor variable. Various names are there. Okay, those input variable, predictor variable, or response variable govern or control variation in response variable, determine variation in response variable, and we want to determine how much variation is explained by the model. Maximum explanation of variation is good for us. The model shall be accurate, the model shall be sensitive, the model shall be reliable. All those performance metrics will be there. And the best model we have to select. And three major types of models are there. Okay, the first type is regression models. And in regression models, this is very basic type, and each and every person have used this in their life. Regression models. Okay. We take some observations, we determine which variable is responsible for changes in those observations, then we plot those. Okay, this height is the predictor variable here, weight is the response variable, and this is the model. Blue line is the model, regression model. Okay, and these are actual observations. Black things are actual observations. Okay. And this, you can see that these observations are slightly deviating from the model, from the blue line. Okay. And that deviation is because of uncertainties. This is the relationship between height and weight of women. A very small data set is available with R. and a very good correlation is there. Almost 99% variation in weight is explained by height. And this can be used to predict if we have some height value here. Okay, height is in inches, weight is in pounds. If we have some height value here, we can predict what weight can be. Or sometimes if weight we have, we can predict height also. That also can be done. And various different regression models are there. Generalized regression, GLMs are there, additive models are there, many different types are there. Okay. Today here we will see, we will not learn about exactly what is the statistics behind the model. Okay. For that, my focus is to help you to use these models. Okay. And to use these models in easier way. If I start teaching statistics here of these models, then that will be difficult for most. Because we all are from very diverse fields, and that statistics sometimes may not be required for implementation of model also. If you want to learn that, then you can learn from various sources. Okay. Many different sources are available. Even Wikipedia pages are also available to explain these things and explain these things very lucidly in a very easy manner to understand. Then this is a concept of residuals. Okay. Residuals are this is deviation, as we discussed earlier, deviation from the actual model. How observations are deviating from the actual model. This distance, vertical distance, this red segment or red arrow is the residual. And each model has the goal of minimizing these residuals. That minimization of residual is or that value of residual is considered as the performance metric or measure of performance of that particular model. But that reduction in or minimization of residuals shall not result in overfitting. Try to understand the concept of overfitting. Overfitting means we have fitted a model or we have trained a model on a particular data. Okay. And the model becomes specific to that data only. If we use that to predict another data or new data, then model deviates from the observed value or actual values. Very erratic values it gives. Okay. If it cannot predict new data, if it cannot predict new data with that same sensitivity, same accuracy, then that model, we call it as overfitted in very simplistic terms. Okay. And for that purpose, to avoid overfitting also, a little understanding of modeling process is necessary. Many variables we need to adjust, we need to modify, or we need to eliminate also to avoid overfitting. Then next type of modeling system or model type is the classification. Third type is clustering. Okay, here I have included both together. Classification models are the models where we know the classes. Here, Setosa, versicolor, and virginica, these three classes are there. And our observations are classified into these three classes. Hello, 1 minute. I'm coming back to. Okay, was the presentation going on, or any interruption was there?
Sir, there is some interruption. Your screen is not visible.
No, sir, interruption is going on, sir.
Okay. Somebody accidentally started presentation from their side, and how control went to that person, I actually didn't understood that. My daughter actually told me that your screen is not working there. I'm starting that screen again. And don't, yeah. Actually, don't wait also to tell me that. You can interrupt. Audience can interrupt. It's a small session. Those interrupts shall be moderate only. Now, I was discussing about these things. Regression models are there. This line is actually regression model, and these black points are observations, okay, and on which this regression model is fitted or trained. Okay. Model fitting and model training both are synonyms. And the distance, this is a different model than this weight height model. This is for a very famous data set, Setosa, that iris is there, and this model is fitted on iris for sepal length explained by the petal length. The red segments are deviations from the model, and the goal of any model process is minimize these deviations. These deviations are called as residuals. Mean absolute error can be considered, root mean square error can be considered. All those measures are to minimize these residuals. Okay. But if you go on minimizing these residuals by adding new variables, then that model can become overfitted. Overfitting means model becomes super specific to the training data. Okay, training data is the concept on which the model is fitted. Okay. If model becomes specific or overfitted to the training data, then it will not predict properly. It will not predict properly. And here I forgot to explain earlier when presentation stopped that this equation is also there. Okay. This sepal length is response variable. This petal length is independent or explanatory or predictor variable. Okay. This 0.41 is the coefficient, and 4.3 is intercept. Okay, intercept on the y-axis, where this line will go through the y-axis. That point is the intercept, that is 4.3. Okay. This is line equation, generalized line equation. Y is equal to slope multiplied by x plus intercept. Okay. Here, just one variable is used as explanatory variable. Here, n number of explanatory variable can be there. N number you can have, but that number shall not result in overfitting. Okay. Those variables shall not add to noise in the model also. Okay. You have to select variables very carefully. That is called as feature selection. Okay. Then many times those variables are not suitable. Those may not have values also. NA values not available can be there, or sometimes many different erratic values will also be there in the variables. If the data is not prepared by you, not collected by you, if the data is collected automatically, many times many errors are there. Those shall be removed to fit the model properly. Okay. Then next thing we'll go for. The next type of model is the classification or clustering model. Both are similar, but in classification model we know the classes. In clustering we actually don't know don't have names to those clusters. Okay. We prepare those clusters separately. Okay. Both are very similar to each other, and in these models, the output is mostly categorical. Output thing. Here that output is Setosa, versicolor, or virginica. And in regression models, output is numeric one. Okay. This sepal length output here, this is numeric. That's why it's a regression model. Okay. And here output is categorical one. Therefore, we have to call it as classification if you know the names of those output classes. If you don't know those names, then it will be called as clustering. And next thing is the confusion matrix. When, as I said here, this is the performance metric, minimization of residual. Okay. Here, performance metric for classification or clustering models is to avoid classification mistakes or to avoid clustering mistakes. Okay. Setosa is here identified most 100% of the time or 23 of the time as Setosa only. Versicolor, little problem is there. In versicolor, 3 of the observations are being identified as virginica. 3 of the observations, because this overlap is there. Versicolor virginica overlap is there, and because of that, this confusion is there. If we try to minimize this confusion, then model may become overfitted. That care we need to take. In Virginica, this 100% of the times it has provided us, and we will see another metrics also. As we go on further, we'll see how this model fitting is evaluated or appreciated. And it's my philosophy that I never make a concept very complicated, and I never think that the concept shall be explained in very tight manner, a very rule-bound manner. I just want to convey the concept, and most of the time that conveying the concepts can be very simplistic. If you want to have some more specification of that, then you have to ask questions. Interactions we will do. This is the flow, how that modeling process takes place. We first have to get familiarized with our data. We shall understand how many variables are there, which variables are there, and what observations are there, what is their range, what is their relationship. Everything we need to understand in data exploration. Not in details. That we will do after fitting, model fitting. But before model fitting, a basic understanding of data shall be there. And if data is not proper, if variables are, if there is the error, like variables have NA values, not available values, or if variables, like if date variable is there, if that date variable is not in proper format, date variable by many programs is read as a character string. We have to convert that character string to date variable. That's very special case is that. And date handling is particularly tedious for any data analysis process. That has to be learned properly. Date handling and many other data types are there. In character data, if your data is logical one, that will also be read many times as character one. That cleaning is very much required, and that cleaning is actually the major part of data analysis process. That is called as data wrangling. And most of the time of data analysis, you have to invest in data cleaning. And when you have worked on data cleaning, you will see how fast that model building process is there. And that data cleaning aspect actually require you to understand many things. And therefore, this 2-hour session is not sufficient to go for the data cleaning. And therefore, we are using the available data set, very easy to understand data set. The properly cleaned data set is there, and I'm very familiar with the data set. Then, when we understand the data, we have to go for regression selection of the model. And if our variable outcome variable, the variable which we want to predict, is numeric, then we will go for regression. If it is classification, if it is categorical, outcome variable is categorical, and we know the names of those categories, then we will go for classification. If we don't have any output variable in mind, and we just want to cluster that data or segregate that data into different clusters, then that clustering models are there. Next concept, the fourth concept, splitting the data is very important for modeling purpose. Two different data type data splitting will be there. We will have our own data, and that data will split. Major part will be put into training data, and some part will be held as testing data. That part will be not, testing data will not be used for training of the model or fitting the model. Testing data will be kept apart. Only training data will be used. Model will be fitted, and then fitted model or trained model will be tested using the testing data. But here we have to take care that both shall have representation from all the variations present in the data. training data and testing data shall be exact replica in terms of variations. If training data has 4 males and 3 females, testing data shall also have, say, equal proportion of those male-female variation. If height variation in training data is, if height is in range 6 to 4 feet, 6 feet to 4 feet, then in testing data also same range shall be there. The statement is variation shall be the same in training as in testing data. Variation in all the variables. Therefore, that splitting is a very, very important process. Very simple methods of splitting are also available. Subsetting are available. In R, you can subset a data very easily. But that subsetting may not represent, or random sampling may not represent all the variations in the data. Sometimes if categorical data is like that, Setosa versical virginica, like categorical data is there. That categorical data, that variation in Setosa shall be the same in training and testing. Variation in versicolor shall be same in training and testing. Okay, variation in virginica also shall be same. Okay. That shall be ensured. Therefore, stratified sampling is necessary for categorical data. And many different sampling algorithms are available. Many different sampling algorithms are available. And in caret, that is done using a special function. We'll look at that. When we split the data, we go for training of the data. In training of the data, it's a very, it will not take much time. If model is simple one, if you have too many variables, if you have some millions of observations, then that training will take time, and that time will be dependent on your computer, configuration of your computer. Your processor, your RAM will be in the picture for training. If extensive computation is required, then your system will be tested for that. For simple models, it will not take much time. And in research, in pure science research, where we collect our own data, we create our own data, our data sets tend to be very small one. Therefore, that training within a few seconds, that training gets completed. And after that, testing comes. And testing is just like we enjoy riding horses or something like that. We do that in testing. Okay, we are now have the fully functional model, and we just want to see whether the model is successful or not. That most interesting part, most entertaining part of modeling process is testing the model. Then why we are going to use caret package? Okay. There are this 238 is very small number. Many model algorithms are available. Here the problem of R programming language comes into picture. R programming language is developed by statisticians to be used by statisticians. Okay. And in R, each programmer programs in different conventions, use different programming conventions. Okay. Different syntaxes are also there. Different keywords are also there. Okay. Each programmer program differently. Okay. And it is being called as each programmer is an artist. Okay. And his program is his artwork. And to understand artwork, we have to, it becomes very difficult. Okay. And for all these models also, it becomes very difficult to remember their syntax, to remember actually the function name of that model, also to use its syntax, what different tuning parameters are there, many different things are there which we need to remember. Okay. And caret helps us there. It provides functions to streamline modeling workflow. Okay. Very important function is training function, then data partitioning, then testing of the models also, it provides functions. Unified interface is there for all those 238 models. Unified interface is there. And it makes easy to model large and complicated modeling process. If very large modeling process is there, its streamlined functions help us to save our time and to save much agony. And that is very evident when you try learning about neural networks. Very popular modeling algorithms are there. And in neural networks, I think 10 or 15 different strategies or more than that also. I have not actually used all those. Okay. Are there to model the things. Okay. And the caret makes that easy for us. And it helps to obviates the need to remember the different package names for each algorithm. It provides a very simple syntax, very convenient streamlined syntax to train the model and to do many other things also. Okay. And it provides very easy way to tune parameters of the model. Okay. Tuning parameters means we play a little with the model so that it becomes it will explain more variation, it will become more accurate, it will become more sensitive, and overfitting will not be there. Okay. For those purposes, we have to play with parameters, and that caret provides easy way to do that. And I have explained that it provides function for data splitting, it provides function for pre-processing, it provides function for feature selection, and it provides functions for variable importance estimation, and many things are there. Caret provides all those functions, and that's why caret is very essential. And you will find caret in many languages. Caret is there in Python also. And I think caret implementation is there in other data handling languages also is there. Because it's a very strong package, very powerful package to deal with data. And the caret is the reason why R is very popular in data science field, in that artificial intelligence field, in machine learning field. Very little difference is there in artificial intelligence, machine learning, statistical modeling, or statistical learning. Okay, very little difference is there. All these processes are made easy by the caret. And here we will use iris data. Initially, we will learn with the simple linear regression, okay, to understand the modeling process. Okay. Then a simple and multiple linear regressions also we will go. Okay. For multiple linear regressions, we just have to add a name of that other variable there. And we don't have to do anything more in multiple linear. But there we have to understand that sometimes interaction effects are there, sometimes additive effects are there. For interaction effect, what need to be done? For additive effects, what need to be done? We are going to see. Then classification models are there. Then clustering models are there, but clustering models we will not learn in this session. And those are exactly the same as classification models. And many a times Titanic data is used for that clustering. Titanic data. And here we are going to use iris data. And this is iris. And for those who have joined late, that you have not lost much, I am going to share recordings and all the scripts and all the presentations which I prepared for this workshop with you. You will go get all those through mail. And after this presentation, we'll start with RStudio. Okay. We'll go to RStudio, and at that time, you all will try to work along with me. I will keep on sharing those syntax with you so that you can see how that syntax is working on your computer. Because programming can't be learned, can't be understood just by looking, just by observing the presentation, just by listening to presentation. You need to work along with. If you see on the screen, 3 flowers are there. Those flowers belong to a plant called as iris. Okay, very beautiful flowers these are. These flowers have 2 flower parts. The flower part on which my cursor is moving is called as petal. Here also the longer part is petal. Here also this longer part is petal. Okay. Below that, the slightly rounded or the oblong shape on the shape on which my cursor is moving is called as sepal. Sepal. Okay. Edgar Anderson was the person who collected data from iris flowers present in a pasture. He collected data on 50 versicolor flowers, 50 setosa flowers, and 50 virginica flowers. Total size of that data is 150. Number of rows in that data, number of observations in that data is 50. These rows are called as observations. Okay. And 5 variables he collected data on.
Sir, screen is not visible, sir.
Again, screen is not visible. Okay, again I will move.
Kindly share the screen, sir.
Visual, sir.
That issue may be because of that visibility issue may be because of that net bandwidth, net speed, internet speed. Sometimes if internet connectivity is not good, then it stops the video. That's
It's
the
quite
issue
visible.
Okay. Okay, we'll move further then. If the screen is properly
Kindly
visible.
share the PPT so that we can open in our system, sir. Because we are not following you what you are discussing.
How to share that
Sir,
PPT?
thing is that I just see the screen, your name and presentations. Nothing is there, sir.
Okay. I will try to understand how to share file.
Yes. Because I already installed, sir, R programming and R studio, and I want to know how to do regression in the R studio.
Sir, it is visible. What you are showing is now I am getting on the screen.
Yeah, but for some people, and they are asking to how to attach file in Google Meet. Okay, can I share I will upload on the drive and then you can download from the this one. Link I will share in the chat box.
No issue, sir. No issue, sir. You can share it in Google Drive. You can also share. No issue, sir.
Okay, I will go to Google Drive. Just few minutes.
Yes, sir. Okay.
All the files. New folder. File upload. At this time, I will just share the caret modeling file. No, this is not. This one, this presentation I will share. Open. It's got uploaded. Hit link. Anyone with the link? Got it. Control C. I'm sharing. I have got the file in where my meeting is going on. I'm sharing this here. Okay, and okay, the registration link also. Now it will be difficult for me because I will share those on mails. And if you want to have the files on mail, then you are I will, if you register here, your mail ID will be there with me and I will share those files with you on the mail also. And at the end, I will try to share these files here also. Okay. We'll move further. Please tell me when you download the file, if it gets downloaded successfully, then. Okay.
Sir, in the Google Drive, if you share, we can download it. No issue, sir. But
Yeah, I have shared in the Google Drive. The link is there in the inbox message, in-call message.
Okay, sir. Okay, good.
Google Drive link is there. You just can click that link, and I have allowed access to all. Therefore, there will be no issue. We'll move further. Now, this data set Iris is very popular, and is very commonly used to learn anything in data science. Okay. Very easy to handle data. No complications will be provided in learning. Therefore, learner will not get demotivated. Okay. Then these observations are there. We'll try to know more about this data. And to more about this data, know more that a structure function is used. Okay. Structure, str, in bracket, the data set name is there, Iris. Okay. It is providing us the information. 150 observations, 5 variables. 4 observations are numeric. 1 observation is categorical. That is a factor observations. Means 3 levels are there, Setosa, versicolor, virginica, and those kept on repeating. Okay. And the summary we will see here using the summary function. Okay. In that, sepal length range is given, minimum to maximum. First quantile, third quantile is provided, median is provided, mean is provided for all the numeric variables. But for categorical variables, there are 50 observations of Setosa are there. It is categorical, therefore range is not possible. Mean, median, mode are not possible. Numeric observations are, numeric summary is not possible. Therefore, we get count here only. Setosa 50 count, versicolor 50 count, virginica 50 count. Okay. We know about the data now that 4 numeric variables are there. Okay. 1 categorical variable is there. In that 1 categorical variable, each category or each level is represented by 50 observations. Total number of observations is 150. Okay. Now, this plot function is a generic function in base R. Okay. When you download R programming, when you don't install any package, that plot function is there. Plot function is a very generic function. Okay. And you can provide the object, and it will plot the object as per the descriptions, as per specification of that object. Here Iris, okay. And that 4 numeric variables, 1 categorical variable, and that's why this plotting is there. Here you can see in these 2 panels, you can see that linear relationship is there. Okay. In these panels also, you can see a fair degree of linear relationship. Here also linear relationship is there. Here also linear relationship is there. Numeric variables are have linear relationship amongst each other. We can see from this, and this can be used for regression modeling. Okay. We can we can use sepal length as output variable, or sepal width as output variable, petal length as output variable, or petal width as output variable. We can use that. Okay. And all other variables can be used as predictor variables. Okay. This next is the function from caret. Here I have called for the library caret. This is always necessary in R. If the function is coming from a package, then that function is not available with R. You have to install the package first. Okay. We'll see how to install the package when we go to RStudio. Okay. Then when you install the package, you have to call the library. Library, in bracket, the caret name. Then that library will be in the memory. Okay. And functions will be extracted or will be imported from that library. Here, this feature plot function is coming from caret. And this function first is the x-axis. Okay, this x-axis. On x-axis, we are using 4 variables of Iris, 4 numeric variables on x-axis. This square bracket is for subsetting. Iris data set is there. I want to subset 1 to 4 columns. Okay, in first, before this comma, row number can be specified. But I don't want to specify any row. I want all rows. Therefore, I have kept this field empty. Okay. And in this field, I have this 1 to 4 is the index for those 4 columns. First 4 columns I want to separate. In y-axis, I want to go for iris, species of iris. Those 3 species of iris will be there. Okay. That 5th column will be there. And plot type will be pairs. plotting shall be each pair shall be plotted. Okay, the same one as the plot function, but here we have to specify many things. Okay. Then we have got different colors also, and here we can clearly see that linear relationship exists. Okay. For some category, that linear relationship is not that correct and is not that strong. Not correct, is not that strong. This is correlation thing. Correlation is very important to study for any data set which we want to model. Okay, correlation. If your variables are highly correlated, then eliminate one of those correlated variables. If here that petal length and petal width, okay, almost complete total correlation is there. This correlation coefficient will be 1, around 1. Okay. Then we can eliminate one of these. We can eliminate either petal length or we can eliminate petal width to avoid overfitting. Okay. Remember this point. Whenever you start modeling, during exploration, try to understand how much correlation is there in your variables. Many times, many people take that cutoff level at 0.75. They eliminate variables or they will use just one of those highly correlated variables or variables showing more than 0.75 correlation. Okay. Just to avoid overfitting. Okay. Overfitting, that elimination of those variables will have cost of little loss in prediction value. That explanation in variable or R squared value will become less because of elimination of that variable, but that will be tolerated, that will be compensated because of overfitting will not be there. Okay. Overfitting means again mistakes in prediction, errors in prediction. Okay. Therefore, we'll allow errors because of elimination of a variable if those errors are less than the errors because of overfitting. Okay. This correlation thing also please remember. And now what we have understood from our data and all these things, regression model can be used and classification and clustering is also possible using iris. Now I think we shall move all these here, that explanation, that modeling process is done, and we shall move to plotting. This thing shall be explained. Okay. This is how to evaluate whether our model is fitted correctly or not. The first assumption for modeling is residual are randomly distributed. Residuals are randomly distributed. There is no specific pattern in residual distribution. Okay. This is range of that sepal length values 5, 6, 7, 8 or petal length values 5, 6, 7, 8. Okay. Throughout this range, these residuals are randomly distributed. There is no pattern. There is no less variation here or higher variation here. There is no specific pattern. Okay. This is first assumption, and our model obeys that assumption, is true to that assumption. Again, another assumption is residuals are normally distributed. Normally distributed means extreme deviation is not there, or extreme deviation is rare. Minimum deviation or zero deviation is the norm, and this symmetric normal curve is a symmetric bell-shaped curve. Okay. And when we want to prove that a particular data is normally distributed or not, we go for this QQ plot, normal quantile plot. Okay. Here, all our residuals are on the diagonal line. Okay. And this proves that our residuals are normally distributed. Okay. The final model, which we have fitted earlier, I have fitted earlier, this is properly behaving. Okay. Then all these things explain the same one: scale locations and residual, this Cook's distance. Cook's distance actually sees effect of outliers. Outliers means the observations which are very extreme. Very extreme. Okay. Those can be errors during data collection process. If those observations are shifting our model to extremes, then our model will not predict properly. Okay, our model will not be that reliable. Therefore, those outliers shall be removed. And this Cook's distance will provide us measure how these outliers are influencing our model. These 4 plots we just get by this plotting one. When this is for regression model, these plots we get for regression model. And when these 4 plots are like this, get satisfied that your model is working properly. And there are other ways also, other very manual ways, dirty ways, which I do many a times. Dirty means non-programming ways. Though little programming is involved there, but that little programming is not that intelligent. Okay, but non-intelligent work is easy to do. Therefore, many times I compare those predicted values and observed values by plotting those scatter plots and all that. Many times I go on plotting those residuals also. Many times I do that just to see whether my model is working properly or not. And that's an interesting process, enjoyable process. That's the success celebration of a model, to look whether the model is behaving correctly or not. Then testing of the model will be there. And this dirty thing which I said to you, I do many times. I have found out the difference here. I did this calculation. Difference is equal to observed value divided by observed value minus predicted value, and that difference is here. And we can calculate, we can have mean of this difference, and we'll square that difference. We'll find out square root of that squared difference. That is root mean square error, RMSE. And goal is to minimize that RMSE, root mean square error. Okay. That mean absolute error is also there, MAE. We don't bother much about that. That's a statistical thing. If you want to learn, you can learn when you get time. But for learning modeling, you just have to know that these are the measures and how those are calculated. You can learn later on. And the residuals are normally distributed. I have plotted this residual myself. These plots are there. I got this plot just by using the plot function. But here I have plotted those myself. Okay, the difference between predicted and observed values. Just for the test data. This is just for test data. This is for total data. All data is used here. Then I have used the Shapiro.test also. This is also dirty work to find out whether your residuals are normally distributed or not. Okay. And here you can see that p-value is 0.95. Means we are 95% sure. This is very naive. Many people actually debate this much. I say that 95% of the time my data will be normally distributed. I say. But they say that it's not. It's the measure to which deals with that probability of false positive or false negative errors, or type 1 or type 2 errors. Okay. But this is a very simple explanation. 95% of the time, my model will behave correctly. Okay. Then this is summary for classification model. No, this is also regression model. This is also regression model, but fitted using random forest algorithm. And this is the report which we get. Regression models using random forest. This is another way. Earlier models are linear models. Earlier models which we fitted here are linear models. And here, this is random forest model. In random forest model, decision trees are prepared by splitting the data. Okay, a very elaborate, very intelligent algorithm works there in random forest. And many variations of random forest are there. If you click here, then you will get list of those models available, 238 models available, and many things. From what is the name of that method, okay, which we will put in the function. Okay, what tuning parameters need to be understood there. Many different names are there. This ROC-based classifier is there, self-organizing maps are there, and here type of one is classification, regression, classification, regression. Things are there, and not all models are suitable for all data. You have to select the model which best represent your data. which provide you with more accurate prediction, which provide you proper training of the data. Okay. That model only. Many times, many models don't work. Those models require data in a very specific format. That is that. But in initial phases, we'll not learn that. We'll just learn how to implement these caret models. And for those, we need to understand these two things. What is the name of that method? Whether it is classification or regression type. Okay, and from which package that is coming. These three, second, third, and fourth column. These columns we need to focus on. This first model name and tuning parameters are important, but during learning process, we can have less focus on these. These 238 models are there, and that link is provided in the presentation. You can go through that. We'll move back again. And that I have fitted actually model to many things. Bayesian regression is there. Cubist model is there. Then this GFS LTRS model is there. Just like Washington's X, I used it on all the trees which are there, or all the models which are there in caret. Most of those, ICR and all those. And those models which are not working, I have not included here. And this is how we get the plots. In caret only function is there to get these plots. Okay. This is mean absolute error, root mean squared error, and only the R squared value. And everywhere it is saying that this RF or random forest, this Bayesian ridge model, qubits model, linear model, all are working similarly. Just ICR model is little less sensitive, little less accurate. ICR model. Any of these models we can use for our regression purpose. Dot plots are also here. This is one another way to show how our model is working and which model is the best one. Here also you can see that linear model, which is the most simplest one and which require less computation power, is working the best. And then this classification.
How to identify which model is perfect or which model is best?
Okay.
Among these all models that you have shown in previous slide.
Okay, we'll move towards that. Where we moved? Yeah, here. The model which has least RMSE or root mean square error or least mean absolute error or maximum R squared value. Maximum R squared value is the best one. That model shall be selected for. Then when you get these values, you can use that for predictions also. Testing, whether that is working with new data or the data which you hold, which you held for testing. You test that model and experience yourself which model is working the best, which model is showing you points which are very closely aligned. Like this, which are showing very small residuals. You can put these plots side by side. Plot prepared by using one model, plot prepared by using other model, these residual plots, and you can compare, which is showing you less distributed points. Okay. This line will be actually, actual points will be on their same place, on their own place, but this line will be adjusted. This model will be adjusted. Okay. Its slope and intercept will be adjusted to minimize the residuals. And the model which is showing minimum value of residuals is the best one. That shall be selected for. And for this one, classification models, this is also for regression. This is also for regression. We are going towards the classification model. And this files, RMD file also, or script I am going to share with you. And in the script, all the models are being shown. Their code is also available. This predict is there. And here, you can see this confusion matrix. This is confusion matrix. Is it visible? I am moving my cursor on the confusion matrix.
Yes, sir.
This horizontal line is reference, okay, and vertical line is prediction. One minute. आणि मोबाईलवरून लिंक याच्यावरून पेस्ट करावं लागेल. This confusion matrix is for classification models, and here you can see that in testing data, 10 Setosa observation models, 10 Setosa rows were there, 10 versicolor rows were there, and 10 Virginica rows were there. Okay. Setosa was identified 10 times. Okay, no mistake is there in identification of Setosa. In Virginica also, no mistake has been done by the model. But for versicolor, because of that overlap, this confusion is there. Okay. And our goal is to minimize this confusion. Okay. And many times we tend to test many models. Okay, we tend to try many. Out of those, only few models will work best. And those models we select for based on this confusion model for clustering or classification models. And here those other parameters are there. Accuracy, 0.933 accuracy is there for this random forest model. Random forest for classification model, accuracy is 0.93, 93% accuracy. 95% confidence interval. This is what I was saying, that statistic. When you go for statistical modeling, when you try to say that this particular value will be there, if you have these observations, this value will be obtained. If you want to say that you are 93% accurate, 95% of the time your prediction will be in this range. Your accuracy will be 77 to 99%. 77 to 99%. And this range shall be accepted. Many people think that model shall predict 100% of the time. Okay? That's not the case. In social sciences, in psychology or anywhere, that 40% accuracy is also accepted thing. 40% correlation is also accepted thing. Because that data tend to be highly variable, and many variables are there which are unknown to us, which we don't have any idea of. Okay. Those governing variables which have control on the output, and unless we include those variables, that accuracy will not increase. Okay. We have to keep on including explanatory variables if accuracy is less, or if R square value is less. Okay. And here that for each category, Setosa, versicolor, Virginica, that sensitivity is provided. For Virginica, sensitivity is less. Okay. Specificity for versicolor, that specificity is 90, 0.90, 0.90. Then other values are also there. Okay. But for other values, the sensitivity and specificity are sufficient to understand whether our model is working properly or not. That positive prediction value is there, negative prediction value is also there. Okay. Then detection rate, detection prevalence, balanced accuracy, 33% of the time it is detecting, because 30 observations were there in the test data and 10 were found to be Setosa. Therefore, the detection rate is 0.33. Okay. Likewise, you will get the performance metric or statistic by the class. Okay. These things, this interpretation of the model many times becomes difficult for many people. Okay. They can fit the model. For fitting model, that is not actually very difficult. This is the code, syntax to fit the model. Okay. This is name of the model, object in which I am saving my model. And train is the function, very important function, train, training the model. That noise is there, please mute that, little disturbance is there. And sorry for that instruction. Species is the output variable here. Species is categorical variable of iris, and that is output variable. This tilde sign is for formula, to specify formula, tilde sign. And this sign explains that this species is explained by this dot is for all other variables. Dot is the shortcut. I can have name of those variables, sepal length plus petal length plus sepal width plus petal width. I can have, or sepal length, that asterisk sign plus petal width, like that I can have. But instead of doing that, this dot is there. Always remember that programmers are lazy people. They want to do anything with very minimum labor, very minimum time. And that's why this shortcut is provided. And that's a very useful thing also. It saves a lot of time. And if you want to specify the variables, then you can put little interruption is there in the voice breaking. Voice is breaking. Okay. Slides to install required packages. Krishna here is asking that the only part is missing in the slides is install required packages and load library the packages. The only part is, yeah, that I have not included that install thing. Okay, and actually that install thing shall not be there in the script, or if it is in the script, then it shall be in a, disabled, because many times people have installed those packages, and if they run the script, then they will waste the time there. That is one. If another question is there, why set.seed was not addressed? Okay, that can be done. That shall be done actually. If you don't set the seed, this set.seed actually, this will make your results reproducible. Whenever we do that again, when we feed the model again, same results we will get. Okay. In initial learning phases, I actually avoid that set.seed thing. And when I start strengthening that learning, when I start repeating those sessions, then I go on adding the details. Okay. And that actually not very well thought strategy also. I have not thought much on that. And I will try to. Many times I will try to include those suggestions. Okay. Is there any other doubt, or shall we move further? Set.seed, two things actually shall be addressed, and those we will do while starting work. We'll go with the new script. Is the screen visible?
Yes, sir.
Yes, sir.
Yeah.
There, now we will address how to install packages. Okay. For that, go to Tools. Okay. Install packages. When you click that, it is taking a little time to give me the dialog box. But here you will get a dialog box where you can type name of the package. Here that dialog box is there. I will type the name caret and then click install. Okay. I have already installed the caret here. Okay. And because of that, this my system will ask the caret is loaded and shall I restart R or something like that. Okay. Here. One or more of the packages to be updated are currently loaded, because those are loaded, those are installed. Okay. If you have not installed, then go for installation. Go for installation. I accidentally clicked that installation thing. And when you install the package, call library. This is very essential. Now I will have to restart my session because of my R is not behaving properly. I will save this. I'll restart R, and you can also work along with me. And this is the script which I'm going to share with you. RMD files also I will share with you, R markdown files, those which you can need, which you can convert to HTML of those. Here, I will call the library. Some noise is there. If you can mute that mic.
Caret.
Yeah. Library. Yeah. I lost concentration. Library caret. Then a very useful shortcut, which I find many people don't know. Control plus enter to run. Take the cursor on the line and press Control Enter, that
Sir,
line.
can you repeat it again, because my R is just started.
Okay. Have you installed the packages earlier?
No, sir. I have installed only R Programming and R Studio. And now
Okay.
R Studio is open according to your instruction.
Okay, it's working then. Just go to Install Tools, Install Packages, and in Install Packages, type that caret. Okay, and click Install. Caret will get installed, and it will install all its dependencies. Dependency means other packages which caret require. Okay. Caret actually very considerate about this thing. It will not install all the packages it requires in true sense.
Sir, it will show caret is ensemble and caret forest. So should we select only caret?
Yeah, select only caret.
Okay, sir.
Yeah, and it will take some time. Okay, because many other dependencies will get installed. We will go further, and I will paste this code in the message box so that you can copy paste that code. Okay, just let it get installed and observe what is going on here on the screen. Okay. This is
Sir, excuse me. Can
Yeah.
I install it from the right side, the packages items here in the yes, this one? Can I
Yeah,
install it
you
from
can.
here?
Yeah. You can.
Oh,
You can
Okay,
install
thanks
from
a lot.
here also. There is another way also. This is install.packages.
yes.
This
Thanks a
command is
lot.
This command is also there. Here in inverted code, you have to write name of the package. And this
Thank you
package,
so much.
it's a beauty. Many ways are available to work with, but I actually go on using the simplest way, which I learn first. I get habit of that, and I keep on using.
Sir, I have a
Yeah.
question.
Yeah. Hello, Mohammed. You were asking a question, or who was asking?
When we install a tidy bus, how can we go to do?
No, little break is there because of net connectivity. Can you type in the question in message box?
Okay, sir. When you install the tidy bus, how can we go to do?
Tidyverse. For Tidyverse is a different one. Now, in this session, actually, I will not use a Tidyverse package. That is the best package, or it's the workhorse of R programming. And it's another reason for popularity of R programming in data science, Tidyverse. And it's not required for
Okay,
this.
sir.
It's not required here.
Okay, sir.
Yeah, we'll move further. This library caret we have called, and it is saying that this loading required packages and all that, and these errors are from my previous work. I will just eliminate this so that no confusion will be there. Another very important thing is remove rm thing. I want to remove all the variables which are there in my environment. And this is the first step for that. Rm list is equal to ls. This thing. I will paste this code in a message box so that you can copy that. Remove all objects from memory. This shall be done before starting any new work. If you don't want to use output of your previous work, then do this step. Otherwise, the objects which are there in the memory, those can interfere with your work. And these rare cases are there, but that error takes some time to find out, to spot out. Rm this run that, then set.seal. This is done For two set.seed, this is my R is not actually working properly. R installation, that's why these errors are there. Or I may have to restart this R session again. But I will try to do with this only. Set.seed. Here any number you can put. Okay. This will ensure that all random numbers will be generated using a same seed generator, same random number generator. Okay. All the random number generation will be reproducible. Therefore, each time when you run that model, you will get the same output. If this is shall be done. Okay, this is advised or prescribed if you want to show your work to other people. Set.seed. If your work is sufficient to you only, then set.seed is not required. But if you want to ensure that reproducibility will be there, if you communicate the results of the data to other people, those shall be the same. Okay. And for that, that seed number generator is a very good thing. That set.seed thing is very good thing.
Sir, excuse me, sir.
Yeah.
Concern the removing function. Is it for removing the all list from R or from my computer as itself?
From your computer memory.
Oh, it's so dangerous, this one. This function.
No, not dangerous, not dangerous. This will not remove from the memory of your computer totally. It will remove from the R session memory. I will correct myself.
Okay.
It will remove from R session memory only. And this is about the garbage which we collect during our previous work.
Okay. So it's healthy function.
Yeah, it's healthy function. It's helpful function.
I have to do it. Okay. Thanks a lot.
Because many times our previous work, those variables may creep in. If you use that name, same name, those variables may creep in, and those will produce error.
I got it. Thank you. Thank you.
When we do these things, just very rapidly, I will go for that head thing. Head shows first few functions. Those who are new to our programming language, this is very useful one. Don't give any focus on this error. Don't have your attention to this error. This error is because of my RStudio is not working properly today. Some issue is working in backend, and I will have to troubleshoot that. But this is not showing me those help and all those things, and that's why it is showing that it cannot open the connection. That head ID.
Sir, where from we check the execution of this command? How do I check and find out? Suppose you giving set.seed is bracket 789. Can I check what is the output for regarding this command? That is command history display.
Okay. For that, actually, it's a R programming question. I will just get randomly selected 5 numbers. These 5 numbers are there. I don't know whether this will provide us a proper answer to this. That random number generation will be reproducible. A is equal to, and this one. Now this time I have saved my 5 randomly distributed numbers in variable A, vector A, and I will ask it to print vector A. Now again, I will repeat the function again. I will rerun the function again. This A is equal to. Now, if we haven't set the seed, this seed, then different set of numbers would have been there. Now, as we have set the seed, when we run it second time, then similar numbers will be there. Exactly same is not there. Actually, I have to find out the reason for that set.seed, how it works. But I have not tested that behavior very rigorously, set.seed behavior. But it is said that when we do that, our work will become reproducible. That random number generation will become reproducible. And our results will be the same when we rerun the program. When we repeatedly run the program, through those repeated runs, results will be the same. That is the function of this set.seed only. Okay. Shall we move further? I may not have answered this properly.
Yes, sir. Yes, sir. Sir, we found that value. No issue, sir. Because random number 5 will generate all the random numbers between the range of 5 numbers. So
Yeah,
it will
yeah.
also consider negative values also, sir.
Yeah,
It is good function, sir. Good.
yeah. It's then head iris, we see first 6 rows of iris. Okay. And we can see the tail also. And many times this tail is also required, and many people prefer to see the random rows also. You know that what is there in the data set, that those structure function is also there. Use that to know about your data, to read what is there in the data, run that structure. The structure is there, those 4 variables, numeric 1 variable, like that. Summary is also there. Summary iris, all the code which we have shown in the slides I am running. Then that plot function is there. Plot iris I am running. And here you can see that linear relationship is there amongst many variables. That feature plot is also there. Feature plot. X will be iris. I will go for indexing. Nothing is there in the row. I will not specify number. After this comma, the column number will be there. 1:4. Okay. And y will be y-axis will be again iris. Okay. I use the $sign to select the species. Okay. Iris species, this one, or I can use this indexing also. This is R programming actually. I'm not addressing the basic R programming in this session. Okay. This feature plot, now here I have not specified the plot type. Okay. I have not specified that. And for that, I will go for here plot is equal to, in bracket, pairs. And then here, if you want to know more about this function, then you will have this question mark and put that. And most of the time, I will keep on working with the command line interface only, or in the script only. I will not go to these buttons or something like that to get the help or to do the things. Okay. Because that saves a lot of time. When I work in command line, when I use the commands and typing the commands, I don't have to move my mouse and to look for the specific button. Okay. That saves the time. This feature plot, when I run this, my button cursor is on the line, and I will press the control enter, or I will go to run. Just control enter, then here you will see the specifications of that, and here examples are there. Okay. And you can copy paste those examples here and run those. Those will work. Those will work. Very useful thing this is, help to learn more about the function. This argument and details here, these arguments are there, and in some function those descriptions are also there. Those help you to learn the function. Okay. And self-learning is the many times best way to learn. Okay. It's a
Sir,
hello.
sir, is iris the name of my file? Iris.
This is data file. Iris is the name of the data file. Data
Yes,
set.
of my data file. Okay.
Yeah, data set which we are going to work now. And
Okay,
if you want to work with your own data, then iris will be the name of your data.
Okay, how to introduce into the R? How can I let R reading my data file?
Okay,
Sorry.
okay.
Okay.
That will we will lose focus from this modeling thing. That is data import thing. Actually, it's not bad. That set working directory is the function. Set working directory. We may have to extend the time little. We'll go rapidly towards that. Set working directory. I will go to my folder. My folder is here. If you are working in Windows, this will work. If you are working in Windows, this is my folder. I will click on the address, file address here. I will click that. I will bring that here in set working directory. I will run that, Okay, I will just add one more backslash here so that I will read that. Double backslash, I will run that. My set working directory is set. Okay, now I don't have actually, unfortunately, files in my folder. The data files here. I will just bring those files. Excel worksheet. Okay, I will copy this file and I will put that BOD file in the folder in which I am working now. Paste. Suppose this is the situation of your BOD got saved. Paste. Yeah, BOD got saved in statistical models data. Now, if this is your data and this data file is in this directory, which we have set here, okay, working directory. You can see that working directory here now. Okay. I'm working in this directory now. When we run this set working directory, our directory will get set. That data frame name I will give here df is equal to, many times I use this df name. That's why that ls function is there, remove function is there. Okay. To remove the previous work, that df read.csv I will use here in bracket, put the inverted quote again, go for the file name BOD, extension is csv.csv and run that. Okay. This file is in R now. Okay, here you can see this file. Okay. Very small file, time and demand. Then this can be plotted. You can work in console also, but if you work in console, that will not be saved. Therefore, my advice is to work in, if temporary work is there, you can work in console. This is temporary work for this session. I will remove that later on. Here, that plot BOD. Look at the beauty of this plot function. And actually, this is not the session. I am moving a bit away from the focus of the session. Okay. This is how we import. I will put this two just for one here. That this is aspect of basic R programming. You can import any data type, but this function is specific for that. If Excel file is there, read underscore XLS function is there, that XLS library is required or read Excel library is required. Okay. That data import thing has to be learned in a separate session. And that's also very easy to learn thing, but many details are there. And for those, we need to go there in this one. Need to learn all those. I will just put that. This is not for this session, but please remember this. Please note this.
Hello, sir.
Hello.
I have a question. Actually, I have joined late. So can you just briefly tell me how much topic we did until now?
Till now, we have explained what statistical modeling process is, what different type of models are there, regression model, classification model, clustering model are there. And now, this is actually the last session where we are going to learn actually how to fit model and how to test the model. Okay, you are not last one. You have just lost introduction part only.
Oh, okay, sir.
Actually, modeling part will start now. Okay. And all this code also I am going to share with you. And for easy thing to save time, I'm sharing this code in a script window, in call message. Okay, you can copy paste that from in call message to learn about that, to run that. The first thing, now we know our data. We will go for splitting the data. Splitting. Okay. And till this time, we have not decided which model will fit. Okay. For this demonstration, we will fit linear regression model first. Okay. Linear regression model first, and then we will move further. And for that linear regression model, we will use sepal length as the output variable, response variable. And this sepal length will be given.
Excuse me, sir.
Hello.
Sir, can you just increase the font size of the RStudio?
Okay, yeah. Just do that. Is it visible?
Yes, sir. Now it is clear.
Yeah. And but because of this, very little values will be there on the screen. the console also shall be visible. Here we can compromise a little, and when required, I will change this. Now, data splitting we are going, and data splitting is required because when we fit the data, that data, if we use for testing, then model will behave properly. We should test the model with another data, different data than used for test training. And if we have a data set, if we use that for training, then we don't get left with any testing data. To avoid that trap, we split the data. This is very small data set, please remember. Okay. Diamonds data set or other data sets are there which are very large, air quality and those which are available with R. Okay. When you work for model business data or something, those data sets are also very large. Marketing data and all those data tend to be very large data. If you want to manage traffic of a city, then also that data set will be very larger data set. If you are working with a fermentation process for production of vaccine or something, okay, then that data set will also be very large one. Or many times, many different data sets are there which you need to combine those. All that require that tidyverse package. But here, we are not going to use very large data sets because our focus is to learn modeling. And if you want to learn other things for better modeling, then another sessions will be there. Okay. That splitting is there. We'll go for the splitting. For that, I will use a vector called as index, a variable, new variable called as index. And in that, I will use the function create data partition. You can see that function here. Create data partition. Okay. And the first thing, if I take my cursor here, that yellow box appears. Okay. That yellow box tells me what should be the first argument, y, times, and all those things. Two arguments are necessary, y, p, and third is the list. Okay. These three arguments are necessary. We will use those. Okay. Y is equal to that iris scalar sepal length we are going to use as output variable, sepal length. That's why we want sampling to take place according to sepal length. All the variation in sepal length shall be represented in the training data, in the testing data also. Okay. That's why this y is there. Okay. After that, we will use the probability. How much data shall be there in testing? How much data shall be there in training? Okay. In training, I will keep 80% of the data, 0.8. 80% of the data will be in the training. Probability of observation getting selected in training will be 0.8. Okay. This is just the index one first. Okay. All the rows which will be there in index, I will select for training one. Okay. List is equal to, this is slightly unfamiliar thing for you. List is a data structure in R. Please learn this. If you don't know data structure, please learn this. And I have included that resources also from where to learn these things. Okay. Tutorial Point is a very good site for that. Or I can market my own YouTube channel also. If you go to my YouTube channel, you will find videos to learn these things. Okay. List is there. List is equal to false, I will give here. True is the default option. True. If you don't use that list is equal to, then true will be used. But here I don't want list. Therefore, I am using list is equal to false. Okay. Now, when I run that, I will get the index in my environment now. Here that index is there. Okay. And when I click that, I can see here. I don't want to. I will see that here. Index 1. It's a data frame. And
Sir,
hello.
can you share us the data file to make a training with you? I can't make any of this function with my data file. Maybe it's wrong in instruction.
Are you working with Iris only?
I don't have the data file from
This data file is bundled with R. It is available with R.
It's available in R.
Yeah, you don't have to install that. It's a bundled with R only. You just type in iris there, you will get all those 150 data points, data observations.
I got it. Okay, thank you.
Yeah, it's available. That's why I used it. I don't have to share this with the participant, and participants don't have to install and don't have to learn how to import data and all those things. Okay, initially, that data import and all those things need to be learned. Okay. Data modeling is a latter part. Statistical learning is latter part of R programming. Basic R programming learning is necessary for that. Okay. Now we have prepared the index, and I will paste this code into message box so that you can follow it. This is actually a shortcut, and where learning is not good because of this. Okay. Learning is not good because of this copy pasting thing. You need to practice typing in the code. Okay. Now we have in index, we have selected those. I will just see what is the length of the index. Use the dim function, index, and you can see that 121 observations are there. 121 observations. Remaining observations we will use for testing data. Okay. Now here I will train data. This is the name of my training data is equal to that assignment operator. Also I have habit to use this equal to, but this is also good for that. This assignment operator. Okay. And not to complicate further, I will use just is equal to only. Okay. Train data is equal to iris in square bracket, the index I will use, because I want to extract the rows. Okay, that index, comma, and all the columns of the index shall be used there. Just one column is there in the index, therefore that will be used. This, when I run, I will have my train data. Okay. Now test data, T capital. Please remember R is case sensitive. If you forget to use that capital or something like that, I have used here this one. Therefore, to have uniformity, I am keeping this capital here or uppercase here. Data is equal to the same thing I am copying. Iris and in bracket index. Just in front of index, I will put minus, so that excluding the row numbers in index, remaining rows will be used. Okay. Test data I will run. Okay. And now we will see the dimension of test data and train data. Train data, run that. In test data, run that. You can see 121 observations are there in train data, and in test data 29 observations are there, or 80% observations of 150 are there in train data, and 20% observations of that 150 are there in test data. Okay. Now this is done. Okay. We have split the data. Now the best part is model fitting or training. Okay. And for that, I will just give the comment here, training thing, and I actually think faster than my typing, and I try to type as fast as I think. Therefore, this spelling mistakes.
I have one question here.
Yeah.
This is Sabir. If we say 80% will be training data, it should be 120, right? So why it's taking 121?
It is randomly selecting. It is randomly selecting that. If you go for the next time, it may take 120.
Okay.
Yeah.
Yeah.
And
right.
that 150, 15, 120 shall be there. Exactly 120 shall be there. But so in some instances, it select exactly 120.
Okay. All right.
Yeah.
Thanks.
It's random selection. And it try to address that question of variability. It try to ensure that similar variability is there. Same variability is there in train data and as well as in test data. This may be because of that. 121 and 29 may be because of that. Okay, to ensure that variability is same throughout. Okay. Now we will move to most important part, that is training one, and it takes very small time, least time, the time required by your computer for computation. Okay, that I will give it model, name will be LM. Okay, linear model I am going to fit. I am going to specify that I want linear model. Okay, if I don't specify, then I will get another model. Default model will be there. Okay. Train function will be there. Train function in bracket. We have to provide the formula. We have to provide the formula for model, and that formula is sample. S is uppercase. Please remember, L is uppercase again. Length. Then this tilde sign, which is above the tab button. Okay, tilde sign. Tab key. Above the tab key, you have the tilde sign. Okay. Then dot I will give. I want to use all those remaining 4 variables as input variable or independent variable. Okay, comma. Here I will use the method. By using method, I am specifying the model, and model name I am using here. If this caret is there, here that model name is there. Okay, and I am going to use model name LM, linear model. Okay. And we can do that. We can do that. But one thing is necessary here, that process control. How to ensure that your model is very correct one. Okay. And that we will include during the training only. Here in training, we will fit many models just using this line of code. Many models. 10, 50 models we can use as per our wish. And for that, we require another object control, and we'll specify that here, control. And that we get using the function train control. Train control, this function. And if you see that help is provided, method, number, repeats, and all those things are there. Okay. Just don't bother about this thing. Okay. Initially, when you go further, when you want to be expert in data modeling, then you can focus on this. But initially, just believe in me and just use what I am saying here. Okay. In train control, the first thing is the method now again. Method is equal to. And I will use here repeated CV. Okay. This is very popular method. In repeated CV, the number is equal to 10, I will specify. My data set or training data, this training data, which I am going to use here, okay, this training data will be divided into 10 subsets. Will be divided into 10 subsets. And those 10 subsets, model will be fitted on each subset. And then performance metric or RMSE will be calculated for all those 10 submodels. Average will be taken. Okay, and this process will be repeated. That repeats, I will give here, repeats is equal to 3 or 5. Sufficient number is 5. Okay, but if your model is very large, then 3. Otherwise, your model will take a very long time, or sometimes your system will crash. Crash means your computer will hang. You'll have to restart. That repeats 5 is sufficient for smaller one. 10 also for smaller data. If larger data is there, then repeats shall be as small as possible. That repeats 5. This is sufficient for train control now. Why it is saying this C shall be small, capital one, uppercase C, train control. You can see what is there in the control by selecting the control and pressing control enter, and it is here. Many things are there which are accepted as default. We have specified these 3 things only: method, number, and repeats. Okay. And that we will use here. Okay. That TR control, again this C shall be capital. Please remember this. Here the difference is their train control, and in this train function, this train control name is different. Train control, okay, is equal to that CTRL I will give here. CTRL. These little issues are there with R programming, that inconsistency. And I think those people are working on that. Those developers, next school is working on that. Here we are using train control function, it is different. And here the argument we are using is different, train control. And we are providing this, which we specified using the train control here, CTRA. Okay. Next thing which is important, and that shall be after the formula. Okay. You shall keep after formula, that is data. Data is equal to. Okay. And here that data is train data. Data is equal to train data, and put comma. Each argument shall be separated by comma. Put comma here. Okay. Now, what is the structure of our function now? Model is there. Okay, this is the model formula. Okay. Then this is data for which we are doing modeling. Method, we are going to use LM, and these are the control features. This is also called as parameter tuning. Okay. And this will be done by train function only. The three functions of caret we have used. One is the create data partition, other is the train control, and next function is the train now. Third function we have used. And with this, we have got the model now. And that model has got calculated. Model has, it has taken just less than 1 second to calculate, because only 150 observations and 4 variables are there. 150 observations and 4 independent variables are there. Okay. Now, we can see what is there in the model. Mod underscore ln. Okay. And the $sign. All the objects which are there in the model are listed here. Model lm is now container, and there all the property of our model is stored. This method is there, model type is there, results are there, best tune is there. You can explore these. Okay. As I go on down, here this important thing is there for me, final model. Okay. Model underscore ln, this is my model, this one. And this model will have many models. Out of that, I want to have the final model, the best model. Okay. And this is the best model. That formula is there, coefficients are there. This is the intercept. This is coefficient for sepal width. This is coefficient for petal length. This is coefficient for petal width. This is coefficient for species versicolor. This is coefficient for species versinica. And why that species setosa is not there shall be the question. Why that species setosa is not there. Okay. And that's why modeling requires dummy variables. This new concept is there, dummy variables, and which we are not going to address in this session. In initial learning, if you try to learn all the things, then learning will become difficult. Just remember that something dummy variable is there. Okay. And that you will address later on. When you face difficulty, try to find solution for that difficulty. You will learn better. Okay. That final model we have seen. Okay. We can see summary of that final model also.
Excuse me, please. I have a question.
Hello.
Hello, I have a question.
You can ask question.
Yeah, what's the difference between this model and the normal model we use with LM function?
With LM, actually, when you fit LM model, LM and old way, I will say that, okay, is equal to LM, and we put there this same one. These three things we put there. Okay. And it works. It works. But here, it is not allowing us to use linear modeling. It is going for quadratic regression model. Okay. That straight line equation will not be there. Okay. Curve will be there. And that quadratic regression is actually based many times instead of that linear one. Because all the local variations will be addressed by quadratic this one. Linear model is true for all those from 1 to last point, but local variations are not addressed by linear model. Quadratic regression address those. Okay. many times this base thing is also sufficient for small data sets, small modeling. Caret provide us that control thing, train control. Okay. It is subsetting data set into 10 groups here. We have specified 10. Okay. It is fitting model to this 10 and trying to minimize the residuals. Okay. This is 10 times more accurate as compared to this for larger data set. For smaller data set, this LM is the best one. Actually, for Iris, LM works the best. Old model. But if complicated data is there, very large data sets are there, then that caret shall be there. Caret is actually a very powerful tool. It's just like earth mover. Instead of using small shovel or something, we can use the earth mover. But for smaller works, shovel is the best one. And LM is the best for Iris actually. But as Iris is the simple one, I am using that Iris. It's simple to understand first. As you go on fitting model to larger data sets, complicated data set, then the caret is the best one for that. Because it goes for the cross-validation thing. Cross-validation. In LM, you will have to do that cross-validation manually. I have done Monte Carlo simulations also for LM to find out how accurate LM can be. I have fitted 10,000 models and found out RMSE. Okay. And as we go on further, that RMSE gets stabilized. Okay. That's the case. For complicated one, take my word that for complicated larger data, caret is the best one. It's the power tool. Caret is the power tool. And if you go to that caret book, which I will provide the link for you, or you can search that on Google also, that caret by Max Kuhn. Caret, Max Kuhn. This book is there, caret package. This books explain that. This caret is short for classification and regression training, data splitting, pre-processing, feature selection, model tuning, variable importance. All these are not available in old modeling functions. Okay. And all those are there. All these models only. LM, the same algorithm is used here. Here. If you go further, you can find LM there. And you think it is using that LM linear model, linear regression, log rake. Don't know whether LM is there. But yes, LM is there. I have seen that linear regression. Old linear regression, methodological regression, all the models are there. That LM is there and it is using the same LM algorithm, but provides the wrapper functions like this control, train control, the train function, that cross-validation thing, and other feature selection and all other functions to ease out, to make the modeling process easy. Otherwise, other things we have to do manually. Okay, here the programming way is there. This modeling with LM, we need to do much of the dirty work. Okay. And if we use this one, then that dirty work is not required. And we are short of time, therefore I will not explain how I am using this LM. But please take my word that I am using this LM for my laboratory work, because my laboratory data tend to be very small, and it's of no use to use bulldozer to or earth mover to dig a small hole. Okay.
Here you mentioned about like number of subsets as 10. Yeah, so basically 120 like 120 data points, it will split into 10 subsets.
Yeah.
Okay.
Then randomization will be there.
Yeah.
To ensure that all the variations get explained.
Sure. Thanks.
Yeah. Okay. We have fitted the model using the train function. That model is available. We are seeing the summary of the model. Okay. And this summary is actually the thing which we want. Okay. That call is there. This is the residual. Okay. We can plot the residuals also I will show you here, same plot we get, plot. This final model will plot there. Final model will plot there. And it is providing us many plots. Okay. The first plot, this one, residual versus fitted. Second plot is normal QQ plot. We have seen that. We have seen that. This is the validation that our model is behaving properly. It is obeying all the assumptions which we assumed during the model fitting. Okay, that assumption is the residuals are normally distributed. There is no pattern in residual distribution. Okay, this model is working there. And this I will try to extract the RMSE also for this mod LM. Here, mod LM dollar final model. This resample will provide us all the resampling things. Look here, that RMSE, all those models are provided here. 50 because we have subsetted it 5 times, and we have subsetted it 10 times, and we have repeated it 5 times. Okay. That's why these 50 models are fitted, and on those 50 models, this RMSE is there. Okay. And if we want to find summary of this, summary, how much range of RMSE is there, we can use this summary. This is just base R programming here. That summary thing is provided. Summary of resample, sorry. I'll have to put that resample. I want summary of resample. Not model LM resample. Summary of resample. And it has plotted that resample to show the summary. Model LM, plot model LM resample. One. I have used the plot function accidentally, and we have got the plot. And that I will just see the summary directly. This summary is there. Okay. Not summary, this model resample. I have lost little concentration. Summary. That time thing is running on my mind. This summary is there. RMSE 0.1963 to 0.4033. This minimum RMSE model is the best for us. Minimum RMSE model is the best for us. Okay. For R squared value, the model which is providing maximum R square is good for us. Maximum R square. Okay. MAE, minimum absolute error, again minimum absolute error is the thing which we want. Okay. If we go here, the best model, the final model, mod underscore LM scalar final model. Of this also, RMSE will be there. This model thing, that all the observations it has used there. Then this is not the proper way to find out RMSE. Final model, coefficients, effects, rank, fitted values, assign, levels, extents, tune values. Tune value will try to find, no, it's intercept. But for final model also, RMSE can be obtained. What RMSE is there to the final model? And here, I will show you. Somehow I lost the concentration and I lost that. Here that minimum value of this RMSE is this one, 0.193. And here you will find that 0.93, that R squared value is there. Okay. And this model should be the best one, should be the final one. Okay. And this model, it's actually selected the final model as this one. Okay. And this model is the best for prediction. Final model is the best for prediction. And this mod LM itself actually shows the final model. Okay. we can use that for prediction purpose. This is for regression. The similar approach is used for classification. That will go rapidly, very rapidly through, because we just have 5 minutes left of that 2-hour session. Hello?
Another question there.
Yeah.
I used to read somewhere about AIC as a way of determining which model fits best.
AIC, yeah.
Yes.
That Akaike information criterion is also there. Okay. That also can be extracted from this. Okay. That AIC value can also be extracted for the model. Okay. That stats AIC is there and that object is required there. That object will provide here. That object will be model LM. Okay. We'll provide it model LM and we'll see what happens. That log leak applied is class train or something like that. It is provided. I have to learn little more about this model LM. That final model thing I will provide it, and it is providing me that AIC is the 62.1787. And this AIC, again, I got trapped in the binary now. So what AIC shall be selected? The maximum one or the least one? And most probably that's the least AIC. The model with smallest AIC.
Least one.
Huh? Hello?
Yes, sir. Smallest value of AIC need to be selected.
Yeah,
I think.
And many times that when I tend to lose my concentration, I get trapped in the binaries, here or there, here or there. That thing happens. But this AIC can be extracted for all the models also. Okay. And the model with the smallest AIC shall be used. We can prepare AIC tables also. And for that, we need to learn a little base R programming. That is required to automate these tasks, because dirty tasks, if I go and finding AIC for all those 50 models manually, then it will take time. I need to have some programming way to find out AIC for all those models. Okay. And I think way will be there, but I have to figure that out. And it's actually the good thing to do that, to find out the programming way for that. Okay. This AIC is there. Akaike information criteria is there. And you can read about that on Google. What is that Akaike information criteria? To learn more about it. Actually, this is one very important and most popular selection parameter, selection criteria. Shall we move further now for prediction thing? Predict thing. We'll just visit that predict and test our model. Okay, pred, I will use that. Pred is equal to, predict is the function for that. And this function takes this mod LM value only, this name only, the fitted model. This model, mod LM, comma. Okay, and this is by choice. This final model will be selected for. Okay. And the data set which we will use for prediction, that is test data. Test data, we'll run that. Okay, and we'll see what is there in prediction. These values are there. Okay, for all the test data. Now we'll plot those to see if exact match is there. Exact match is there. Those shall have one-to-one relationship. Okay, if both are similar, that prediction. And for that we will see the table data dot frame. I will use that. This iris. Not test data, sorry. Test data, scalar, sepal length is my observed value. Okay. I'll keep the name here observed is equal to, okay, and put the name here predicted. Predicted is equal to pred. Okay. When we run that, PRD is there. PRD. When we run that, we see that this is the observed value, this is predicted value. Okay. We'll give name to the data frame, DF results. I will call it as DF results, and we'll plot this data frame DF results. And when we run that, okay, we'll have to run this, we'll have to run this. You can see here that sufficient diagonal relationship is that. If you want to plot that there, then we'll have the this one, linear model there. PF race, scalar PRD is determined by PF race. These values we are going to plot. Don't bother much about. Just I am plotting those values from this data frame, the PF results data frame, and this line will get added. You can see a straight line is there, and this is actually our regression model. And these predicted values are also following that regression model. Okay. And here the intercept and all that 4.3 intercept and all that will be obeyed. Okay. Our model is true to the training data also and true to the testing data also. That this RMSE value, AIC value, and this diagonal plot, that little deviation is because of uncertainty, because of deviations in the data. We have got this. These values, predicted values, are not exactly on the line. Just one variable is not involved here. Okay. We are just using these two, but other variables are also there which are governing this point. It shall be a multidimensional plot to show that all those are there on the exactly on the model line. Okay. Multidimensional plot. Here, that multidimensional plot cannot be visualized. That's why this distribution we can see. Okay. This is the thing. And if you don't go for that, then you will get the random forest model. And actually, LM model is the best one for this. I will share the other scripts also with you. If you go through those scripts, you can find out that I have used other models also, which I have shown during the initial introductory presentation. Okay. Shall we move for the classification model? Just one example of classification model we will use. We are out of time now. Hello. We are out of time now. Shall we move for classification model?
Yeah.
Yes, please.
Okay.
Yes, please.
We'll go rapidly within a few minutes. We'll try to do that. Classification model. And clustering models are also the same. Basic. When you go towards the basic, all is same. When we want to go to the details, then little difference is there in the details. Okay. And we are not bothered for the initial session about these details. For that, again, we need to split the data, because earlier we have split the data for numeric output, and here we need to have the categorical output. Therefore, that train data, test data shall be different. I will go for the remove again. Is equal to ls. I will remove all the objects from the memory now. Okay. That set seed is not required here, or we can go towards that also. We have set the seed earlier. I don't want to have the garbage of the objects which I created in earlier session. That's why I use this one. Here I will prepare index again, but this time for that create data partition function, I will use species as the y. Y is equal to iris scalar species. Okay. This one, create data partition. Probability, again I will use 0.8. Okay. This time that earlier question of that 121, 29 will get addressed. Okay. 0.8 is here. List is equal to false again. And we'll run that. We have the index. Now, we'll have the train data. Train data is equal to the iris data set we are going to use. Okay. In bracket now, rows from the index I want. This process you are familiar with now, comma, all the columns I want in train data. This is there. Test data is equal to that iris thing is there. Okay. You can go through this video again and again. I am recording the video. Okay. To understand this process, you can go through this video again. You have my mail ID. Okay. And you know my Facebook handle also. You can use that. You can use any platform to ask any doubt. Okay. I will try to solve that. If very lengthy doubts are there, then only I will If I don't have sufficient time, I will not go for that. In test data, that index shall have minus sign, so that those from the index will not get selected for. Okay. Train data, test data, their dimensions we'll see. That train data, dimensions, and here you have 120 now. It's a categorical variable. Therefore, its variations will get addressed because of that 120. Other in that variations were not getting addressed by 120. Therefore, 121 was there. That beam test data is there. That 30 is there. Okay, 120, 30. Proper 80-20 partitioning is there. Okay, this is called as data partitioning also. Data splitting is called as data partitioning also. Okay. Now we have there to split the controls, specify the controls. Okay, we have skipped that feature selection here. Feature selection and feature engineering. Okay, that is you have to do with your own data. If your own data is there, very large data is there, and if that data has many errors, NA or something like that, you have to go for feature engineering, that data cleaning and all that thing. If over correlation is there, you have to go for that removing those highly correlated variables also. But for learning, this initial learning, I assuming here that you are getting initiated to caret, initiated to data modeling. Okay, there don't go towards that. Okay, initially, okay. As you fit 10, 12 models, then try to include one more detail that. Here, that train control is there, function, train control to get the control parameters. Okay, that method is again the same one. I could have used the earlier object also, repeated CV. Okay. And then number, again I will use for 10 number, repeats, I will use 5 repeats. Okay. That control is there. Okay. Now we'll go for model fitting. Okay. And for that I will give name model, RF, random forest, I will use here, then LM, not LM, CL, classification. Okay. Model underscore RF underscore classification. RF can be used for linear modeling also, regression modeling also. For any regression modeling that RF works. RF is actually many people go through it. That GBoost is also there. Okay. It's a decision tree. Again, another decision tree methods are there. Many models are there. And RF is very popular. Neural network is very popular. LM is very popular. Okay. And for classification also RF work. Neural network works for classification as well as for regression also. But some neural network algorithms don't go well with regression models. Okay. That you will understand as you go on further. Okay, I have actually tried all the models while preparing for this session. Here we will use the train function. The train function takes the formula, that is species, is my output one, that tilde sign, dot for all other variables. It's a shortcut for all other variables. Then data, my data is coming from train data, okay, comma. Okay. And this script I am going to share with you. Therefore, concentrate on the what is going on my screen. Okay, it's no need to go on yours, work on your screen. You can work that later to save our time. Okay. Then that train control is there, TR control, and please take care of that lowercase uppercase thing and spellings also. Many times I do spelling mistakes and I find those very difficult to address later. Okay, that take my time. Train control, train data, method. I was forgetting the method. Method is equal to RF. RF is the default one. Even if you don't use that method here, it will use RF. RF1, when we run that model, training is going on now. It is taking some time. RF requires some computation, and it has got. Summary, and RF summary will be shown different. Hello. RF summary will be shown in a different way because this summary, it will show according to the RF algorithm or RF package, and this summary is there. Length and all that thing is there. Again, we will have the final model also there. This model object is there. This one, final model. Final model is there. And here in final model, you can see the confusion matrix. Now this summary, that RF package is very good package to show that this confusion matrix is there. I don't have to go for that confusion matrix. We'll again go for confusion matrix, but this is provided here. 40 Setosa observations there. It has identified those Setosa 40 times. 37, 40 versicolor observations were there. It has identified 37 correctly and 3 it placed in Virginica. Overlap is there. And that thing shall be allowed. If you go for 40, shall be addressed 40 times only. All the correct observations shall be there. Then it will become difficult. That overfitting will be the case. Okay. Then 535 is there. This is on the test data. Okay. OOB estimate of error rate, something like that. This actually works here. Okay. Out of bag, some observations it take for fitting the model, some observation it keeps for testing, and very many things go on at the back end because of this control option, which we have included here, trend control. Okay. And that it has provided us the summarized information, that estimated error rate 6.67%. If we ask it 100 predictions, about 7 predictions will be wrong. Okay. Then number of trees, all that information is there. Random forest, number of trees, 500 trees. For each model, it has prepared 500 decision trees. Okay. Number of variables tried at each split 2. Like that much is going on behind in the random forest. And because of that, it was taking some time to calculate. Okay. And this is the confusion matrix. Okay. Now we will predict. Pred, I will use again, predict, same thing. For any model, same thing is there. You can reuse this code. Okay. That is the beauty of caret. You can reuse this code for any model. Just change the method name. We'll do that. Predict is equal to model name mod RF underscore classification mod, okay, comma. We will use test data for that, okay, and we'll run that. Now we'll see there what is there in prediction. For that, we'll use the data dot frame, okay, and then there we'll have the test data pillar species. In other column, we'll have predicted one, and we'll run that. You can see how correctly it has identified. And then confusion matrix automatically provide us that information. For test data, it is not committing mistakes for test data. In train data, it has little problem with that. And here, when we have the confusion matrix of this, two, okay, it compares this line by line, and if error is there, it will show us. This confusion matrix is there. No mistake RF has committed here for test data. 95% confidence interval is accuracy will be 0.88 to 1. Okay. Actual accuracy, observed accuracy for model on the test data is 1. Okay. P value is very small. Our model is statistically very significant. Okay. Possibility of that model getting here by random chance. That random chance probability is this one, very small probability. And because of that, this model is actually statistically significant. This is again another parameter for performance. Kappa 1, kappa is equal to 1. The 1 is the best one and 0 is the least one. Worst model will have 0. Kappa 1 is the best one. McNemar's p value will be NA because all are proper. Exact correct identification is there. That's why this McNemar's test p value is NA. And the statistics is there. Everywhere you will find that RF is working better. Okay. If you want to use another model there, just change the name, and sometimes it may ask to install some packages. Okay. Caret will ask you to install some packages, give the permission there. If the package is not there on your system and caret require that, then caret will ask for. Okay. gboost I will use here. I don't know whether it will work or not. Okay. gboost is not in caret's built-in library. I will go here to find out the model. Cubist model I will use. It's for regression. Cubist model is for regression. GLMNet is for classification and regression both. We'll try GMNet. EV3 is also for classification and regression. And don't know how much time they will take. BAG FDA, these models are there. Flexible discriminant analysis. I will copy this. I will try to use this. And if it works, then it's a great thing. And then I will start learning about this FDA. I will just put this RF only and copy paste this code. Okay, let it be. I will use this only to save the time. And that was FBA. I'll just confirm. Yeah, it's FBA. I will run that. And it is asking me that mode get CTR function in a parent frame control earth response of mode function was not found. This is little that FDA is not compatible with that train control or something. Then we will go for another one. LM ADA boosted classification tree copy. I think this will also work or not. I don't know. ADA, but the same code is there. Little tweaking may be required. It is asking me to save some packages. That ADA package is not there. Try to install. Yes, I will give it permission. And if that package is working with my version of R, then only that package will get installed. Yeah, it is getting installed. Package error. There are 50 or more errors that ADA is produced. Okay, this is because data conventions, that data formats and those may be required differently. Okay, little different thing is required, but that we can learn. We can learn what is required. If we have time to go through that, then we can learn that. This k nearest neighbors model also we will try. The same code works there. KNN, k nearest neighbor for classification or the clustering. Again, yeah, it's working. It's there. I'll see the summary. Okay. Summary is there. It's the beauty of caret. That's why caret shall be used. And its training set outcome distribution, Setosa identified 40% of the time, Mercier identified 40 times, Virginica identified 40 times. Out of those 40, means correct observation is there. Okay. That prediction thing we will go. Okay. That prediction thing is there. Data frame, what is predicted, okay. And Setosa identified as Setosa, all the things are true. Okay. Confusion matrix. Again, we can go for confusion matrix. Again, this confusion matrix is there. I will just take it up. That accuracy is 1. Everything is working fine with KNN also. KNN is working properly. That this one, all the information about KNN is there. 9 nearest neighbor model it has used. K is 9 here. Training set outcome distribution, this one, and it is working better. Okay. Hello. And just now, I will share all the scripts with you. On the mail, I will share all the scripts, so that all the scripts also will be there. All my presentations will also be there, and other material also which I prepared for preparation of this session. Go through that. Try to understand it more. Many issues will be there. Many problems will be there. And participation certificates, actually 600 registrations are there. And I thought, took this as informal session. Okay. No participation certificate will be there. Okay. Later on, if you want to learn details, details of this modeling process, then a 5-day workshop will also be there. I'm planning for that 5-day workshop. But as it's a one, that will be lengthier one and more details will be there, then that will be paid one. Okay. But if you have any doubts while learning on your own, then you can ask me. I will try to solve those doubts. Okay. You have my mail ID. You have my Facebook also. You can message me using Facebook messengers also. If you want to learn more out of these processes. Okay. Many things I may not know, but I know that because of my R training, I can learn a little faster. Okay, and there we can save on time.
Sir, can you share us your YouTube channel? URL?
Yeah, that will and
URL
are joining. That YouTube channel URL I will share. And that is there. It's called there in. That will be there in the script also. I think I have included.
Yes, I found it. Yes, but it's more easier here.
Yeah. That how to share my channel. Welcome to this station. I'll find a way to share. I think this is. I'll go through this. You can click the video. I will share this link only. I'll share this link only. You can go through this video. Many videos are there.
Please paste it. Yes, paste it in our chat.
Many people couldn't join earlier. Those are joining. Actually, I'm going to share all those. Almost 600 registrations are there. Were there. And I will share all those files with this recording also with all those 600. Hello, David. Want to ask some question?
This is Samir. I'm using R version 4, and it says random forest is not available for R version 4.
Yeah, and for that you need to download the latest version of R programming. That happens when they update the packages. They update those packages to work with the latest R version.
Okay.
And here also you might have seen those errors in my system also. The latest version is 4.1.2.
Okay.
I'm working in 4.1.1. And on my Linux system, that 4.1 is also not there. It is 3.6.
Okay. Okay.
Therefore, many of these things are not working there on Linux system.
Sure. Okay. All right. Thanks.
Sir, sorry. Concerning this question or this issue, I have R also. Sometimes when I create a code and going to output the plotting, the plot doesn't appear in the plot area. It's open UR Windows and show me the plot. From what's the wrong in this issue?
That is dependent on the object format. If that is plot object of R, then it will open in that plot window. If that is HTML output, then it will open as a HTML viewer. That will be shown in viewer window. That happens just because of output format of that object. Here that viewer is there. Okay. Sometimes those files open in the viewer, and sometimes those files, if neural network and those are there, if you want to print those neural networks, then they will open as separate HTML files, HTML windows.
Okay.
Yeah,
okay.
That is because of that object type. Those object types which are not R object types, then R will try to open those in different windows, their specific windows.
Okay. Thank you, sir.
Welcome.
I have one question, sir. May I?
Yeah.
I followed the code, but whether is it possible that I get some minor deviation of the results? The codes are fine.
Yeah. It's possible because of your system. Those random numbers differently.
Okay. Because I got through the course, but I am getting the results like accuracy, like some for some random forest, I got it around 99%, and that intercept value was a slight deviation from what it was being shown on your
That
window.
is perfectly okay. That's why that the set.seed is required.
Okay.
If I use that set.seed and the same seed you use, then you will get the same results as my results.
Okay.
But for those, that R version shall also be the same.
Yeah, mine is 4.1, so might be that might be the reason. Yours is 4.1.1. What I am using is 4.1, I guess. So
Yeah.
might be some deviation in that.
That may be there. And for Python and SAS,
Okay.
actually Python is for more disciplined people.
Okay.
Those people from engineering and those engineering or physics or chemistry, or those people who can think in abstract way, they, for those Python is there. And actually I tried to learn Python, but I found that R is the best one for my purpose.
Yeah. I have also used Python, like some beginner level I have used, but I find R is better as compared to that Python for our point of view.
Yeah.
We are not using the visual animation or something like that.
Yeah, therefore, it's difficult for me to have session on Python, training session on Python. And SAS, actually SAS is a paid platform.
Yeah. R is far better. I think it's because open source we get a lot of information from internet also. Want to know the basics and we can follow the course very easily.
And because of that reason only, SAS is installed at my institute. But actually, I don't have time to take sessions from the institute. If such sessions are there, which I am managing on my own, then I have to be dependent on my own system there. Therefore, I don't have any commercial software on my system.
Yeah.
This Windows is also by accident I have. Otherwise, I would have used the free Linux version also.
Thank you for this class. It's a very, very important session. And
I will go for the paid version also of that, for 5-day session paid version. For those who want to learn on details.
Okay, you can share us the details of that training.
Yeah, I will share with those. That dilemma is actually there. But if I am investing much time, then that compensation shall be there. That philosophy is there. Otherwise, I find it very difficult to go for paid version. That little hesitation is there. But a 5-day session I will try to arrange.
Okay. That would be great. Thank you.
Any doubts are there? I arrange sessions for data visualizations also. For basic R programming is also. I think basic R programming will be the best one. Again, we may have 1 hour or 2 hour session for basic R programming, because many people need.
Yeah, it would be great. It would be great, like ggplot2 and some data visualization part. That would also.
Yeah. I actually do that ggplot2 also, because my students don't require that R programming. They think that only ggplot is sufficient for those. And that's why most of the time I keep on focusing on ggplot2, but that's not good. Our basic R programming is also essential.
Yeah, even this caret I have used for the correlation coefficients we get to weed out, like to distinguish, like I want to know like a correlation coefficient above 0.8 or 0.7, like that. For that we use this caret package. So that's where also this caret is also helpful.
Yeah, that is caret is actually very good to provide us many those helper function or facilitator functions.
Yeah. For selection of PCA variables after correlation coefficient, we did use this caret also. That was also.
That is feature selection. Feature selection. Highly correlated variables we can eliminate.
Yes, exactly. Yeah. Thank you so much.
PCA can also be done using caret. Okay. David, you have again another question? David hand is raised. David Marrow, do you have a question? Okay. I think this is if you want to know more, if you find any issue, any question, then you can ask me, and you can mail your feedback also to me. Your feedback, how much you like that, and about my accent also, my very strong.
Sir, we need a Python session also.
Yeah, that
Python.
Python. Actually, I said that I'm not too good at Python. And my own opinion is Python is for disciplined people, people who can think in abstract way, people who can think with mathematical precision. That physics, mathematics, engineering, those people can go very well with Python. And I am a biologist.
Yes, me too, a biologist.
Yeah, I tried to learn Python, but I found it difficult to go with.
Sir, can you create some WhatsApp group so that we can share your views and our research problem with you? If you think to create some WhatsApp group so that we can join with your group and share our views on, because
that WhatsApp group actually tend to be very closed one many a times, and that WhatsApp interface, many messages will be there, and out of those messages, important messages may get masked on WhatsApp. That
Telegram is more preferred, yeah, sir.
Yes, sir.
Telegram.
Yes, sir. Those who are really doing work in R, they are shared their views with you, so you can don't worry about these things. You can create in Telegram group, and we are ready to join with you, sir.
Yeah, I will try to do that. I will try to do that, and we share that on the mail.
Yes, sir. Another thing, sir, we are communicate with you through email ID. So
Yeah. That's also will do. If you can communicate on email ID also, I will try to.
Sir, I am a research scholar. Hello.
Yes.
Little noise is
Hello,
there.
sir. Hello.
Hello, Karina.
Okay, the training is very fine, and if it is possible, if you arrange such software on the next day, it's possible.
Okay.
If it is not possible,
sir, I am also working with.
If you arrange the other software rather than the especially on agricultural productivity, it is very difficult to analyze the data. So if you rearrange also.
Okay. For the basic R programming also will arrange like this session for basic R programming. Actually, I not got the entire question. Okay. If you can type that question, will that be feasible? Possible? Can you type the question, Kalina?
What you have to say?
Can you type in the question?
Okay, I will type on my questions on the message.
Yeah.
And
in the message. Yeah. David's question was whether the results will be the same in another one. Yeah. If you are using R commander or something, R code will work there also. It works there. If you are using basic code editor, script editor of R programming, then also this code will work there. RStudio is free one, and in my opinion is the better one as compared to other options. In my opinion. Yeah. Hello. Okay. David's hand is also there. Okay. Sometimes I find it difficult to find. If I don't understand the question, then please type in the question. Yeah, RStudio interface is better to work. No, here, David, for this session, I used the built-in data only because this session is introductory session for caret. It's possible to use import the data from your drives, from your computer. That is also possible. But that importing, to teach importing also will take some time. We lose focus from modeling them. Therefore, I use the inbuilt data. I have not edited that data. That data is there. It's a perfectly clean data from our programming. Talila, what was your question? I asked you to type that in.
Yeah, so the connection is disturbing me because of that, especially on pictorial, especially when you analysis the data on the console part, the pictures or the plot didn't speed up to come when you analysis. This is one of the reasons.
Okay, are you asking about image analysis?
Yeah, image analysis.
Raster data and all that?
Yeah.
Are you working with spatial analysis, spatiotemporal maps and all that?
I didn't use, especially I have used in data analysis. I have used in ANOVA. In ANOVA, after you analysis the data, the ANOVA structures, when you go to the picture, the pictorial analysis, it is very difficult to speed up.
Okay, I will have to find the reason out. What is happening? Many times, actually, if you are working with pictures, if I am getting the question correctly, if you are working with pictures, then your system's RAM shall be very high for graphical data. And ANOVA and that, I will have to connect those again. I'm not connecting those properly. How to put that ANOVA data or superimpose data on picture. That little accent issue may be there for me also, and that little I'm not getting the question correctly, Talila.
What to say?
If you type in, then that will help.
I type it on the message.
Yeah. What happens that my Indian accent, and I'm very habituated to learn the Indian accent. One of my friends is not there in the meeting, but he actually helps me to understand the accents. He actually worked with many people from many different countries. But problem is that when I start RStudio, then Microsoft Defender needs to stop. Any suggestion from your part, sir? In Microsoft Defender, there may be some permissions. If you use open Microsoft Defender settings, in settings, the allowed applications or allowed apps may be there. In those, you have to allow that RStudio. The similar thing like with other antivirus softwares, because try to write something on your disk, your drives, and Microsoft Defender prevents that. You have to allow to write on the drives, and you have to give that permission using settings of Microsoft Defender. That can be done. And exactly that system to system differences may be there, because here on my system Windows 10 is running. Windows 11 will have different settings. Don't know about that. And you can mail me the questions also. If your questions are there, and if I'm not answering those properly in this session, you can mail me those. I will work out the solutions and will share those solutions with you.
Hello, sir.
Yes.
Okay, thank you for the floor. I have a question that's not concerning the presentation that you did today. It's concerning my personal work.
Yeah.
In fact, I am trying to I am trying to calculate the correlation between variable before start with the model, and the variable include both categorical and numeric variable, just to know how to test the correlation between all the variables together without separate them.
For that, I need to see the particular data, and you can share that code also with me. You can share data file. If you believe that I don't use that data anywhere else, I assure you that I don't use the data shared with me.
Okay.
I can work on that data and I will provide you the solution.
Okay, thank you very much.
Yeah, I will do that. And you have my mail ID. You can use that mail ID to communicate with me.
Okay.
Yeah.
Thank you. I'll do
This
it.
is for all also.
Okay.
If very lengthy solution is there, if time-consuming solution is there, then it will be difficult. Otherwise, for smaller one, I will do that very easily and very rapidly, very
Okay.
promptly.
Okay, thank you very much.
Yeah. Okay. The last question is that I'm using the R software to analysis, but when I use ggplot, is very slow to show the plot, and this is because of the RAM limitation of the system. Many times, if you are working with 8 GB RAM, and if your data is very large, then R try to pull all that data into RAM, and that RAM gets flooded. And because of that reason, RAM doesn't have any space to do the calculations, to send the calculations to processor and to take the calculation results from processor. If R gets insufficient RAM, then that slow thing will be there. That is the question of this one, RAM situation. 8 GB RAM actually has many issues with Windows. 8 GB RAM. And I was working till 1 month ago. I was working with 8 GB RAM, but I had to upgrade for my molecular dynamic simulation. I had to upgrade to 16 GB, and that's why my system is working with this much efficiency. That issue is there with R. It pulls all the data into RAM, and if larger data is there, then the slowing thing will be there. And the only solution is go for increased RAM. And the session, actually the time was issue. I didn't communicate time properly with this. Next time I will try to include that zero time. Therefore, most people found it difficult to join in time. But I am going to share a video of this session with all of you. Google will take some time to share that video with me. And when Google provide me that video, I will share link of that video on my mail. Or I will put that video on YouTube. For laptop users, what do you advise on configuration of laptop for maximum RAM? If you are working on Windows, then for routine work, 8 GB is sufficient. 8 GB for routine work. If your data is slightly larger data, If you have millions of rows, then you will have to use higher RAM. 16 GB RAM is sufficient. 16 GB. 16 GB. Processor can be i3 or i5. Currently, i5 processors are there. i7 processors are also there. i3, I think generation 8 or something will work better. Okay. But if I am considering about Indian rupees, then the laptop of cost 50,000 rupees. How to convert that into USD? So 50,000 means that may be 100. $7,000. $750 or something. $500 to $750 laptop has this configuration. Around 16 GB RAM, i5 or i3 processor of that 8th generation or something like that. That laptop works better. How to block multiple line in R with single command or operator? Pushpa, this is a very good question actually, and there comes a very good philosophy of R, that is piping. Piping. You can do piping using that pipe operator. It is just like Unix pipe. A very long code, entire long code can be converted to a single command. Okay. And if you want to do further thing, then you can prepare your own function. Okay. You can write your own function and provide little argument, it will work. Okay. Actually, I have written these functions which we have used, caret and all those, train and all those. These functions have very large coding at the back end. But we have to specify some arguments and it will provide us required output. In single line of code that works. Okay. To go for that, you can use piping or you can use function to do the repeated work. Okay. I'm doing with biochemistry assays, colorimetric assays and all those. And for that, I have a function. There I will provide my concentration, I will provide my absorbance readings, and the function provides me the analysis with the plot. Okay. Just a single line of code. Function is required for that. Yeah, I am going to Barhanu Makonnen. Pardon me for my wrong pronunciation of name, but I will provide recordings, link of recording to all those who have registered. All those. I know that time issue is the problem. I will send you. And if you have any issue, then you can mail me or you can communicate on that Facebook Messenger also. And Pawar sir, thank you for appreciation. And that Yasin Galer is there, is not seeing my desktop. That may be because of network bandwidth issue. Okay. And shall we stop here for today then? It was quite a lengthy session. It's 3 hours now.
Sir.
Yeah. Hello, huh?
Yes, sir.
We can stop.
Yeah. We will stop here then. You can leave the meeting. Sneha, you were asking something, and thanks for joining. Thanks for joining. I enjoyed much with you people.
Thank you very much, sir.
Yeah, actually, I love communicating with people. Sneha?
For installing random forest packaging, 3 options are shown: random forest explainer, GLS, and SRC.
The first one, select the first one.
Okay.
Yeah, it will work. David, do you want to ask something? Okay. I will try to post those on all the Facebook groups where those R programming thing is there. I will try to post my next sessions, or I will put those, I will send you mails also if I arrange another sessions. Okay. Thank you, Samir, for appreciation. And FB link.
Thank you very much.
Yeah, I will share my FB, and that FB is there on my YouTube channel also. My Facebook handle is there. Facebook ID is there on my YouTube channel. I will share that with you. Okay, after this session, I will share the video. I will share my scripts. I will share how to communicate with me. All the platforms of communication I will share with you. Okay. Okay. Shall we stop here for today then?
Yes, sir.
Yes, sir. Thank you.
Welcome. Welcome. I'm stopping the recording now. And if you want to communicate something to me, then you can put this in comments. I will go through the comments and I will try to address those. Yeah, Pushpa, big data analysis is possible with R. R is very strong in that, but only problem with that is our system configuration. Many times our computer RAM and our processing power becomes a limiting factor for analysis of big data. But that can be done. When we learn more about R, then we can go for parallel processing also. That is also possible. Yeah, I will share another training through emails. I have your email IDs. I will go through that. Okay. Okay. We'll stop here for today then.
Yes, sir.
Okay. And if you want some specific help also, then you can mail me. And believe me, trust me that I will not share your data with anyone else. And you can play with that data also to keep it secrecy. Just send me a proper example, workable example on which I can work the solution. Okay. 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 We'll stop here for today then, and I will share my next workshop sessions also with you. Okay. I'm stopping the recording now.